and welcome to the Desk of Ladyada. We're back.
Hey everybody, it's a lovely Sunday evening and we're back at my desk of Ladyada, to do a follow-up part 2 on last night's exciting Nordic NRF52 Metro build. So last night what I did is I sketched out the design by taking an old Metro circuit board, taking out the Atmega 328, taking out all the parts that we're not going to be using, and then pasting in the Nordic NRF52 module and all the components that go with it, so you can make basically a Bluetooth low energy version. This is based off of our NRF52 Feather. So we're pretty sure that the schematic is all good, so all we have to do is do the layout. So last night I think we had 50 minutes total, and we basically took the Metro, gutted it, and kind of did the pin configuration. This morning I did a little bit more pin configuration. I wanted to multiplex a couple pins that I could. For example, the Bluetooth indicator LED is now multiplexed with like the DFU pin, and the single wire debug output pin is multiplexed with the factory reset. These are very rarely used pins. So on the off chance you need to factory reset, you're probably not going to be doing that at the same time as debugging. You're going to do one or the other. So I don't feel too bad about multiplexing those. And then this is the final design layout. There's one wire that has to be routed because I'm not sure I actually want to connect this. It's connecting the 5-volt pin from the SPI port to, I'm not sure whether I want to connect it to the 5-volt pad or the higher of 5 volts and the li-poly battery. So I'm still thinking about that. But all 250-ish other air wires got routed today. And it was a couple hour process. It takes about 2 hours to route that many pads. It takes about half a minute per wire. But instead what we did is we recorded it while I did it, and also meant I could listen to music, because we're going to show you a time lapse of the routing process, which is much more exciting than watching me route for 2 hours.
That's right. So we're going to shrink it down, beep, and then we're going to play this. And when you have commentary, I'll bring you in, and you'll be Ladyada talking about Ladyada routing boards.
There's gonna be 2 of me.
Yeah.
Pretty exciting.
All right, so here we go.
Okay, so you can pop me up because I'll start talking pretty fast.
Yeah, you're gonna get in here.
All right, let's go. Let's
Bye.
do this thing. Okay, so start from the beginning.
Yeah, here we go.
Okay, so this is where we left off. I decided to put the module over there on the right-hand side. So the first thing I did is I just got rid of the ground plane, because the ground plane is very confusing. I like to route without the ground wires in the way. So once I did that, I basically started connecting the most populous wires that are over here. So all of these are the bottom pins are GPIOs, and those go straight up. So basically I had to, the thing is the via holes I have are a little bit larger than the wire, so I have to kind of do this squiggly, wires go out and then wrap around. You can see how they kind of curl around each other to get all of the pads out to vias and then all the way up. So they go pretty much right underneath the module. Now I just cleared up the DRC, because now I'm actually starting to route. I'm like, okay, I'm going to do a DRC check pretty often, make sure that, I like to pack things in tight, but not so tight, of course, that it can cause manufacturability issues. So next up, this is the crystal over here. So this is the 32 kilohertz crystal, and then those are the analog pins. There's like 4 analog pins. Making a little bit of space by moving the crystal up and then the analog pins out. So again, the nice thing is, because this module can have pretty much any pin on any pad, like for example here, I'm doing the SPI pads, and I end up rearranging them so that this one goes out here, this one goes around. They don't intersect each other. So that's one of the nice things that you can do when you have a microcontroller that is really flexible. It's rare. Usually microcontrollers, even like this AMD series, is you can't have I2S on anything but a certain couple pins. I2C only a couple pins. On this chip, it actually allows you to use pretty much any pin for any use, except for the analog pins. So then I've got, this is like a DC-DC converter. This is for low power usage, which is pretty nice. It can actually, I think the core voltage is like 1.2 or 1.8 volts, and it'll actually have a little DC-DC converter that steps down the 3.3 to 1.8 or 1.2 or whatever. So that's kind of nice. So I do place those components. Next up, I'm getting the reset circuitry. These two pads are a little, they're a little weird because they're underneath the module. And so they're kind of in like a place where the module doesn't like it that it doesn't actually like wires underneath there. So I kind of like bring the wires back a little bit. This is now the 3 volt power line. So this line here, that's the 3.3 volt power line. That's why it's so thick. And I also put a 0.1 microfarad capacitor in there. Now I didn't have it in the schematic originally, so I added it. I like to have a 0.1 microfarad right next to the power pin, and then a little bit farther a 10 microfarad, so you kind of get both together. That gives you best low and high frequency support. Now I'm going to do the LiPo charger section. So over there is the LED. The LED is right next to the jack. This is the connector. And then I'm grabbing, this is the 3.3 volt regulator. And then down here, this little guy over here, this 5 volt, this is the LiPo charger. The switch is connected to the enable pin of the regulator. So that switch will allow me to turn on and off the 3.3 volt power, which is pretty cool. I think that's like there's a couple little things here, like I try to measure the voltage on the battery. This is the Bluetooth LED, so that's controlled by the module. So I'm just making a little bit of space because I have a red pin 13 LED, yellow RX, yellow TX, green power, and then I have the fourth blue for Bluetooth. And then I'm just kind of rearranging it and putting the resistor nearby and getting these LEDs all nicely connected. The blue LED, again, it's a firmware thing. Our stack controls it, so I assign it to any pin I want. Now I'm doing the other two analog lines, and I'm just sort of cleaning some parts up to make space for it. I'm checking out the grounds, making sure my ground looks pretty good. Let's see, I'm doing the power lines now. So pretty thick traces for the 3 volt, 5 volt, ground, VN. These are the nice thick, I think they're 20 or 24 mil traces. Now I'm doing the reset protection circuitry. So to make it easy to program, we have, like the Arduino Uno and derivatives, we use the DTR pin on the USB serial converter to reset the chip to get us into bootloader mode. So I need these little two components to protect from over voltaging because there's a spike up and a spike down. So I just have a little diode clamp. More power supply, just making the traces nice and thick for the 3 volt, 5 volt. The 5 volt comes from up here, the USB. 3.7 volts from the LiPo down here, and then they kind of come together, the 3 volt regulator. Let's see what's next. I think this is the RX and TX lines. This is the reset line. I think I rearranged a few pins on the module to make it route a little bit nicer. One thing that you do have to watch for is there's a couple lines that are near the radio antenna, so I'm gonna have to warn people, hey, don't use those lines for timers. Not a good idea, but I think it'll be okay. They're connected to the UART, which is, these two pins here are connected to the UART. They're not super high frequency. So now we're doing pins 12 and 13. And then these are the lines that come from the USB serial converter, which is this chip over here. And those two lines come out this way. And then the reset button and the reset circuitry is up there. It also has to come down. More power supply stuff. Fidgeting. I love the power supply cleanup because I kind of put it there and then I moved it. I do my GRC, just quickly checking some things. Now I'm doing the NFC antenna. So one thing that's interesting about this chip is it has the ability to act as an NFC client, so you can pair without having to pair. But those pins, they are fixed pins. They have to be these two pins, these two right here. So I'm making space, shoving things over to make space for the two capacitors. And then I'm going to have two through-hole pads that I can solder a antenna to. I might also put a board level antenna, but I'm not, I made space for it, but I'm not sure exactly if I'm going to use it. This is where I ended up changing to 5 mil to really, you can see I'm like tightening things up, and these are the two through-hole pads. Done a lot of space here, and I don't want to bring the wires too far out. Those analog pins, I want them to be as close as possible to the pads out down here. Okay, so this is the SWD connector that's used for debugging. If you are going to be using this with a J-Link or OpenOCD or GDB, it has built-in debug support. So I ended up deciding to put the connector up there. The debug pads are actually down here, but I thought, well, I'll just bring them underneath the module like the rest. And the nice thing about this location is that the debug wire can come out and it won't interfere. I don't want the wire to be in the way of another connector. So the way I put the connector is the cable kind of comes out nicely and won't interfere with a shield or something. So I'm just, making some space, moving the pads around, connecting power and ground. I do a commit because I'm kind of getting close to done. I think I have about 25 air wires left. So this is where I'm like, okay, I might end up undoing a lot of work because I'm really starting to noodle. So I'll do a git commit to save my work. This is the DFU button. This is a button for like, you really did something terribly wrong with the bootloader. You have to force your way into the bootloader, or you're using it with Minute or Zephyr or something, some other non-Arduino bootloader. You might need the DFU pin. So I do stick a DFU connector there, button there. Now I'm sort of like trying to get all those wires away from the antenna as much as possible. And now I think I'm at like the last 10 air wires. So this is kind of where it gets a little, not hairy, but it's like things really get like pushed around. I think I swapped 2 pins here. I swapped an LED and factory reset pin. And then I have like one last pin here. I have to snake this out. And so I end up moving all of these parts around to make space for one last via. I think that's the pull-up for the debug output. That's the reset line for the debugger. All right, so all the components are now placed. Sometimes, I place the components as I route them, but eventually I'm like, okay, all the components are now placed. Now I have to finish my route. So there's that last one. So you see I move all the wires out of the way. I kind of zigzag them out of the way to make space for one via. Kind of push things out. This is where a push and shove router would be really awesome, but this version of Eagle that I have doesn't have one. So you can see I kind of like shove everything around a little bit. And as I'm doing it, I'm constantly running the DRC to make sure that I don't make a wrong assumption about how close I can get a component. So you can see I push all the vias up and out. You can see the little zigzags, push them out of the way. And this also gives me a nice ground that can come in here because I'm going to need to have a nice ground plane underneath the module. So you can see all of the pads purposefully that come out via and then underneath. So the bottom layer isn't going to be a full ground plane, but right here where my hand is, that will be a ground plane. If I really care, by the way, the module itself also has a ground plane, so it's not like, it's a 4-layer module. It's nice to have a nice ground plane underneath it as well. I don't feel like I need a 4-layer board here because, again, the module does it. So now I've pulled the ground plane out. I'm tweaking the ground to isolate because I want it to fill in. It was a little bit too thick. I had it at 12 mil, but I want it to be, I think I set it to 10, so it would fill in nicely. And now I'm sort of shoving things around to give myself a nice thick ground path here and a ground path here. And then I'm gonna, I make space so I can put some vias. Yeah, good times. More vias. Staple that ground plane in. Then I want to clean up underneath, so I turn off the top layer, and now I'm just working on the bottom layer, and then, packing the traces close together. So getting as much away from the antenna keep out area, which is right here. You can even see it says keep out. So more moving, getting out of the way. Don't want anything underneath the antenna. Keep that clear and keep as many traces away from it as possible. Okay, so what's interesting is I'm not doing any, the traces, I'm trying to keep them kind of neat, but they're not going to be perfect 45, 90 degree angles. I actually do that after my first schematic has been verified because it takes like 2 hours to do the route and then 2 hours to get like all the traces perfect 90/45. So I was like, you know what? I'm going to verify the schematic, get a prototype made, then I'll go and make all the traces, you know, thicken all the traces I can that have a lot of power that maybe I missed, make them all 45, 90 degree. Here I think I'm also trying to make this power path. Here, remember this is the 3-volt power line to the module. It's the only power pin. So I'm like, okay, I want to have a good ground connection near that as well for the ground return. Because the ground right next to it is the power return. Okay, I think here I was just like cleaning up some power supply stuff. Maybe 1 or 2 last traces. This is actually, now I turned on, I had ground air wires off while routing. I turned them back on. Now I'm actually doing my ground route. There's no point in routing ground wires until you're done. Like, you know, you want to get all your signal lines that are picky, and then you do your ground and power. And I think this is kind of where I finish, and then I'm just trying to, I look for places where it looks like the ground plane is pinched, and I kind of move parts out of the way. I'm also trying to move parts away from the silk screen, so a little bit of cleanup. This is a ground enable. Kind of like, how's this looking? Maybe get these reset components a little bit higher out of the way so they don't interfere. The silk screen will change, but I wanted to make it, you know, maybe the reset stuff should go next to the reset pad rather than near the Arduino reset pin. And then I move the jumper next to the label, route it, clean it up. I think, yeah, you maybe wear the skull.
That's how you know it's done.
That's how you know it's done.
You did it.
I kind of shifted off, but here I am. So I wore the skull mask.
Yeah, you're done.
And yeah.
Okay, so can you... Okay. So, we're finished. Oop. Thank you, other Ladyada.
Yes, that was my skull. Okay, so this is the final design. So, yeah, the silk screen's going to change. Big. These things down here are going to stay the same, but this Metro, you know, it's probably going to shift to the left. And then I left those pads for the NFC connection down here. They're these 2 holes. But what I'm going to do probably on the 2nd or 3rd revision is this whole area here, which is just totally empty. There's like nothing here. I'm going to move all these traces out of the way, and then I'm going to put, I'll take away the ground plane as well, and I'll turn that into a little surface mount NFC antenna just by having traces that go around like an inductive loop. And we'll have to tune it, but then you can press it up to your phone and pair it. Kind of interesting.
Okay, question from the chat.
Yeah.
Does bouncing the signal backwards through the via lose some of its effectiveness?
You know, if honestly, you know, if you have enough vias and they're small, it doesn't make a huge difference. Not at the power, like this isn't, there's not that much power. You just want to have a reasonably good ground plane. As long as you have one clean one, like in my opinion, it's better to have one big ground plane like underneath the module, so you have like basically something for the antenna signal to reflect off of, than to have 2 like kind of half-assed ground planes. And that's why if you look here, the underneath, the blue is completely cut up. It's all traces, but the red top, hold on, let me turn off this silk, it's confusing. But the top layer is nice and big. You just need it to be the same size as the antenna, which you do, because
they're small traces, so I mean, they're not going very far.
No, they're not going very far, and it's actually like this here. This is where it reflects off of. This is where the antenna comes out. So having good ground connection here is the most important.
Okay, that's it for tonight. This is fun. This was an experiment to see how this time-lapse routing 2-part video episode would go with commentary and more, and you did it.
Yay!
Good work, Ladyada.
Time for a prototype, but
okay.
I think this is good to go.
All right, that's it. Say
All
good
right.
night.
Good night.
See y'all during the week.
Skull.
Bye-bye.